Well, a very, very warm welcome. It's just been drawn to my attention that today is, in fact, our second birthday. It's been a wonderful 2 years, and we're looking forward to many more years of these conversations about corrosion. Now, in our current series, we've been discussing the hidden dangers associated with cathodic protection. But as we close off the series today, we really didn't want to leave you with a negative impression of cathodic protection.
Now, hang on, Vanessa. You're not allowed to say that because cathodic protection is all about making things negative. So we actually want people to go away with a very negative impression in that they need to make sure that their pipelines or structures are negative. And whilst we put positive to pipe to read negative values, it's no wonder people can get confused. However, let's leave it there.
Okay, we'll walk away understanding that cathodic protection is negative, but we're trying to leave you with a positive impression about it. Through our series, these last couple of weeks, we've been talking about how we can categorize some of the hidden dangers associated with CP. We looked at putting them into the categories of physical, consequential or electrochemical, and social categories. We've spoken about vandalism and the scourge that is. We've talked about the risks of cathodic protection when there's too much of it, or if there's interference associated with it. And we thought it would be here today to see if we can identify some of the ways that we could reduce these, quote, hidden dangers and remove the fear that cathodic protection seems to evoke in many, many people.
I think the biggest issue that we've seen in the industry, and when I say the industry, I mean the infrastructure industry, the pipeline owners, the pipeline operators, the consulting engineers who manage the construction projects and so on. The biggest issue is that people don't understand cathodic protection. And unfortunately, in the past, there has sometimes been a tendency for people to actually make cathodic protection look like a black box phenomenon, which of course it isn't. It's a very straightforward electrical system, and it follows electrical laws and it follows electrochemical laws. So it's actually a well-behaved physical and chemical system that we're talking about. But because it crosses so many boundaries in terms of discipline, electrical, chemical, electrochemical as a result of that, construction, geology, and then operations and so on, people tend to shy away from it because it makes them think. And sometimes people don't want to think. However, this whole series that we are involved in is trying to raise awareness amongst people who are involved with buried structures, be they pipelines or jetties or foundations or tanks or anything, where there is this possible issue of electrochemical interaction. And by raising the awareness amongst people, they then know to ask questions and to seek advice. I mean, you wouldn't go to a GP for a heart transplant. You would go to a heart transplant specialist. And so whilst we don't want to transplant any pipelines, we definitely want to make people aware that there are specialists around who can address these issues, and the operators and constructors and owners shouldn't be shy to ask questions. Now, it's been my experience over the last 40 odd years that there is one very, very significant event that causes people to sharpen their minds and loosen their purse strings. Guess what that is?
A pipeline leak.
Absolutely. There's nothing like a pipeline leak to sharpen the mind and loosen the purse strings of the pipeline operator. The result of that then is that you land up with somebody who asks questions. We had a project a while back where the project engineers said, well, why are you worried about temporary cathodic protection during construction? We install a pipeline and take some measurements, and then maybe in a couple of years' time, we'll install the cathodic protection, not realizing that here in South Africa and in other areas where you have interference corrosion, you cannot afford to wait that long, because if you wait 2 years before you do anything about it, you've already got a leak.
No,
and sometimes it's even worse than that. One of the very early projects I was involved in, we did a design and supervised an installation on a new pipeline that was installed through one of the consulting engineers. And then that all went very well. It worked and got commissioned. And then there was another even bigger project that involved installing a new pipeline parallel to some existing pipelines. And again, we put in the proposals for the cathodic protection, and the client went, "Oh, no, that's much too expensive." So nothing happened. And about 2/3 of the way through the construction, when they came to do the pressure testing, they found that there was a leak that had occurred in a low-lying area where there was, in fact, bacterial corrosion, which is very rapid. And that all of a sudden made the use of cathodic protection far more palatable. And we landed up then retrofitting the cathodic protection, which now, of course, was much more expensive, rather than putting it in during construction.
I think just your anecdotes right now, Neil, have highlighted the importance of a corporate memory. And I encourage everyone who's present today to see what you can do to start rebuilding a corporate memory. You know, in generations past, people would stay in one job for life. And today we have a much more fluid workforce. So I recommend that as one of the ways that we can help with the awareness. Obviously, attendance at bite-sized corrosion is something that we advocate. But in your own workspace, try to create some sort of documented structure which can speak for the systems when there are no, can I call them older, grayer voices to remember when.
I think one of the challenges is that when cathodic protection is doing its job and working, it's something that is out of sight, out of mind, doesn't affect the amount of water that comes out of the other end of the pipe. It doesn't affect the fuel or the gas or whatever. And when it stops working, you don't see the results of that immediately. Not like a mechanical problem, say, with a pump. You know, if a pump fails, then immediately you have no product going through the pipe. If a CP system fails, well, the pipeline will continue to operate without any trouble for maybe 15 years, or if you're lucky, or 15 months or 15 days, depending on the severity of the environment. The challenge is that you don't know then that you've got a problem until you really have a problem. And that then becomes a panic. And that brings me to an interesting little 4-point summary, which has been dubbed the corrosion cycle. It starts off with either ignorance or neglect, whichever you want to call it. People don't know, so they don't do anything, or they don't bother to keep things operational. And as a result of that, you then get a leak. When there's a leak, or maybe might not have been a leak, but maybe you've lost 90% of the wall thickness of a pipe when you do an intelligent pig survey. And then there is panic. We've got a corrosion problem. Help, what do we do? And everybody runs around and becomes an instant expert. And all of a sudden, all the parameters that the corrosion engineers have been trying to implement are brought into sharp focus. Everybody knows better. Why aren't you doing this? Why aren't you doing that? Why aren't you doing the next thing? What about this? What about that? And so on. Somebody once likened this to Brownian motion. For those of you who've studied chemistry in your past, you'll know that Brownian motion is totally haphazard and just goes in all directions at the same time. And out of that, eventually, you'll end up with a corrosion maintenance or management program, which we can then call the good practice of corrosion management. And that goes on until we lose some corporate memory again. And people say, oh, now why are we paying all this money to take these measurements? Nothing ever happens. Why are we paying for this electricity account? It's got nothing to do with water, switch it off. And so that lands up in what we can call almost an unlearning curve or a state of complacency, and the corrosion cycle starts again. And this cycle can last a few months if you're unlucky, or several years, by which time people have moved on.
That's exactly right. And I think that what we're endeavoring to do in this forum really is to keep cathodic protection front of mind so that we don't end up with that out of sight, out of mind scenario. And one of the challenges with cathodic protection is that we become afraid of it, I think, because we forget how it is working, or we forget that it is working. And I'm hoping that out of this discussion, you start to feel empowered and you start to feel as though you're back in control in that corrosion management scenario, as opposed to the haphazard running around. And if your infrastructure is not under cathodic protection, it's worth investigating to see if it has previously been under cathodic protection and the system has just fallen into neglect. Maybe you'll be the savior of the system, of the pipeline, before we get to that panic because of a leak.
Well, there's sorry to interrupt, there's another thing that you've just brought to mind, and that was a situation with one of the major water boards in South Africa, where there was an engineer who recognized that there was an issue, and he systematically went about collecting data from the plumbers who did the repairs, then systematically addressed these, put in hotspot corrosion protection where necessary, and brought the leak rate down from, I can't remember what the actual units were, but say it was leaks per kilometer per year or something like that. He brought the leak rate down from something like close to 100 to something like 2 or 3. I think it must have been leaks per 100 kilometers per year, probably, because it was a vast network that they were dealing with. And as a result of that consistent management, they reduced the leak rate due to corrosion to virtually nothing. And then the corporate memory got lost because the person retired. The new management didn't know what he had been doing. The new incumbents didn't know what to do. And the leak rate has just soared again. And we all know how much water is being lost in our systems. It's reported in the press regularly. 30% of the water is not paid for. Where's it going?
Neil, if we go back to your little corrosion cycle, we can say that even today, the attendance at today's presentation and through this series has to some extent removed or reduced the risk associated with ignorance, because we've been speaking about corrosion. And as I was saying a little while ago, instead of going to the panic, let's short circuit that cycle and let's go straight to practicing good corrosion management, because now you're aware of some of the dangers associated with cathodic protection, and you've got some idea of what to look for and what the concerns are if we don't monitor our cathodic protection. So if you have a company policy that encourages interpersonnel communication, you can encourage regular in-house reminders to keep the cathodic protection of your infrastructure high on the risk, on the radar, so that it doesn't become a risk and it's no longer hidden. And as I think I said in one of our previous sessions, as soon as something is in the light, it's not hidden. And as soon as we keep reminding ourselves about it, we're drawing attention to it, and it's less likely to be so fearful. But there are some risks, and I'm not unaware of the challenges that vandalism is resulting in. And I think we can spend a lot more time on the topic, but Neil, just briefly, some thoughts about moving away from the high risk impressed current system where there's a power supply that's got major appeal, where there's obvious copper involved, which has major appeal, where there's above ground infrastructure, which maybe if I bash it down, I'll find something worthwhile, and where I'm no longer reliant on our fairly irregular grid power, and move that to something like sacrificial anode CP?
When I first started in the industry, sacrificial anode cathodic protection was quite common on pipelines, and generally it was applied as hotspot protection. And we spoke about hotspot protection yesterday when we were talking about some of the challenges associated with continuity. Irrespective of that, if you've got a continuous pipeline, you're not going to get corrosion throughout a pipeline. If you've got a pipeline that runs through, for example, agricultural land with the occasional dip into a flay or a marsh, for those of you who are not in South Africa, then you will find that the corrosion issues take place in the highly corrosive areas, because those are the areas that are anodic in what we call the long cell action that is associated with a pipeline. So if you provide hotspot protection in the areas where corrosion is going to occur, it's not necessary to actually protect the entire pipeline. The part of the problem of that is that you need a far more comprehensive resistivity survey to start with. But then at the end of the day, you put in this hotspot protection, and as we saw with that network that I quoted earlier, it works. And it doesn't matter if it's not protected in the middle of the agricultural land, because that's not the area where corrosion is going to take place. And that's actually reflected in the ISO/SANS standard that we use for cathodic protection. Because if the resistivity is high, typically if it's higher than 100 ohm meters, the criterion for cathodic protection drops to minus 750 for cathodic protection. And if it's higher than 1,000, it drops to 650. 650. So if you're in areas that are non-corrosive, you don't have to have the full-on protection. And that is something that doesn't apply when you're using impressed currents, because in impressed current, the current goes everywhere, and you've got to provide the current for the entire pipeline to protect it. With sacrificial anodes, you can in fact get away with using fewer anodes.
You can be more selective.
You can be more selective. But having said that, the other situation that has developed compared to what we had in the 70s and 80s last century, that sounds dreadful, doesn't it? Is that the coatings are that much better, that we don't need as much current. And therefore, sacrificial anode protection becomes far more attractive. And we can start using things like zinc anodes, where the lower driving voltage of the zinc is not so much of an issue because we don't need so much current. And we've recently had a situation where a pipeline that had a short section that was put under sacrificial cathodic protection for various reasons. It was a 10 kilometer section, if I remember correctly. The entire pipeline was something like 60 kilometers. And the impressed current system on the balance of the pipeline failed due to vandalism. And the sacrificial anode actually landed up protecting the entire 60 kilometers. Which was quite amazing, and I was surprised about it. But it just goes to show that the new high resistance, high integrity coatings really do make a difference.
Indeed, and Neil, even if you're using a zinc anode or a magnesium anode, you've still got sufficient current to overcome anaerobic bacteria corrosion or SRB corrosion, because Correct. Your potential is still more negative. That was just a question that was raised from the floor.
Yeah. I mean, for bacterial conditions, we want to keep the pipelines more negative than minus 950. And you can do that with either zinc or magnesium when you have these high performance coatings.
Daniel, I think there's also merit in going back to the way things were, of ensuring that on new projects, there's someone who flies the corrosion flag, shall we say, on a new project, and possibly starting to encourage municipalities, water boards, infrastructure owners to start reinstating cathodic protection or corrosion protection as a division within them.
Absolutely. I was absolutely shocked the other day when a colleague contacted me and said that they had been in a meeting with one of the biggest national infrastructure developers, if I can call them that, where the financial management had queried why was it necessary to have a corrosion engineer on the project team for a major pipeline project.
If we can say penny wise, pound foolish, they don't have to have it, but the major pipeline probably won't be carrying any fluid by the time the installation is complete if they ignore corrosion.
Yeah, they'll be distributing the fluid along the route of the pipe.
Indeed, which is an irrigation system if it's water, but it's an environmental nightmare if it's a petroleum or a oil or something. And I think just to highlight the fact that the cost of cathodic protection, although it seems high, is actually a minor cost on any project, and the consequences are enormous when there's a failure without cathodic protection.
Yes, I think the project cost is something like 5%. If you look at the cost of implementing cathodic protection on a major project. And if you fail to do that and you've got to go and do rework, well, the rework costs 10 times what the original would have cost. And that doesn't include the repairs necessary to fix the results of corrosion. Cathodic protection can't put metal back on the pipe. It can only stop it coming off. It's not like electrowinning or electroplating, whereby if you reverse the current, you can put the metal back on the electrode. Once the metal is gone, it's gone. And the only thing you can do is dig up the pipe and repair it. And the cost of excavation is phenomenal compared to the cost of actually patching the pipe.
I hope that these few comments have helped you, our listeners, to make wiser decisions in terms of cathodic protection, to not be fearful about cathodic protection, and to be aware enough to ask for help if you're feeling out of your depth. Now, I mentioned yesterday that we are launching a course on our Teachable platform called Brush Up, which is focused on coating inspectors. It was drawn to my attention, our course being titled Brush Up made us think of a great in the paint industry, Mr. Mike Book, and he sadly passed away a year ago today. And so it seems quite special in some sense that we've been able to launch a course focused on coatings inspection, a subject about which he himself was passionate, kind of on the anniversary of his death.
Well, what's particularly special about that is that we've entitled this course Brush Up, and Mike Book was famous for his little club, I can almost call it, because it wasn't a formal association, which was called the Brothers of the Brush. I don't know how many brothers I still have around, having been one of those original brothers decades ago when it first started. I think it was in the 1980s. And so, Mike, your Brothers of the Brush are keeping the brush going, and we hope that brushing up on the very, very important aspects of correct coating application and coating selection, coating integrity, and so on, which is a very real part of making sure that our cathodic protection systems work, and that will provide some additional awareness and a fear not factor that is necessary, I think, really, in the long-term performance of our infrastructure.
Right. So with that in mind, I'm going to wrap up today to say thank you so much again for joining us through this series. It's been wonderful to see so many familiar names each week. And we really, really do appreciate the time that you take out of your day to spend lunchtimes with us as we talk about corrosion. Thanks for joining us.